The self-siphoning chain, defying gravity before your eyes. What if I told you a simple metal chain could spontaneously leap out of its container, forming a beautiful floating arc against gravity? Now, this mind-bending phenomenon looks like magic, but today we'll reveal the fascinating physics that makes it possible. And you can try it yourself with just a chain and a cup. This incredible demonstration is called the Mould Effect, named after physicist Steve Mould, who first explained it. When a chain flows over the edge of a container, it doesn't just fall straight down, it can actually rise upward first, creating a spectacular fountain-like effect. The secret lies in an interplay of forces that transforms downward motion into upward movement. To recreate this phenomenon, you'll need a smooth, flexible metal chain 1 to 2 meters long. A tall container, glass beaker, or mug works well. A camera to capture the slow motion action, optional. 1. Prepare the chain. Coil the chain loosely in your container with one end hanging slightly over the rim. Start the motion. Gently pull the dangling end downward to initiate movement. 3. Observe the magic. Instead of flowing straight down, the chain will rise up, forming an arc before cascading downward. 4. Experiment. Try varying the height of the container to see how it affects the fountain height. 3 key forces create this anti-gravity illusion. C1. Tension propagation. Each falling link pulls on the next one, creating a wave of tension that travels up the chain. 2. Upward reaction force. As links are pulled down, the container pushes up on the remaining chain with equal force. 3. Rotational dynamics. The chain's stiffness causes it to pivot at the rim, redirecting some downward momentum upward. These forces combine to create a feedback loop. The faster the chain falls, the stronger the upward kick becomes, making the fountain rise higher. Critical height. The effect only appears when the falling distance is sufficient, typically 30 centimeters. Chain matters. Stiffer chains produce more dramatic effects than completely flexible ones. Energy source. The free upward movement is actually powered by gravity acting on the falling portion. While this looks like just a cool trick, the physics has important real-world uses. And space tethers. Understanding chain dynamics helps design space elevator concepts. Deep sea engineering. Similar forces affect anchor chains and underwater cables. Industrial processes. Conveyor systems rely on controlled momentum transfer. The chain fountain teaches us that even simple objects can reveal profound physics when we look closely. What appears impossible at first glance becomes understandable when we analyze the forces at play. Try experimenting with different chain types or container shapes. Does a wider container change the effect? How high can you make the fountain go? Share your results in the comments. This experiment reminds us that the universe is full of surprises hiding in plain sight. We just need to know how to look for them. If you enjoyed seeing gravity seemingly defied, hit like and subscribe for more mind-blowing physics demonstrations. Next time, we'll be making liquid climb walls with no pumps or magic.